Okay, let's remember for problems like this, where we have an equation and we're asking what is the value of x, we could always go through and take these values and plug them in for x and put these guys into our calculator and go through and check to see which ones are congruent or same decimals. You could also go through and really think about how all of this is going through and saying, well, if I know that this simplifies to 4 square roots of 3, how did that 4 get on the outside? Well, that really meant it was 16 originally times 3, which then means it was really a 48 underneath. How does it equivalent to being this? Well, x would have to be 2 here, right? 24 times 2 would give us that 48. For this next problem, when you go through and look at this, you have a lot of reading with this. And remember, we're talking about LCM. And so the first thing I was actually looking at was to go through and see, well, what am I looking at when it comes to my variables here, my x's as my bases? If I know the LCM is x to the 5th, that means, remember, if I think about like that lots of money, to remember that if I have an x to the 3rd compared with x to the b and my LCM is x to the 5th, if I'm going to pick the one that is greatest, that lots of money, remember we think about with the L's and the M's, that means my B had to be the 5. So if I go through and look at my 4 answer choices here, A is still in the running because it says the exponent must be 5. This one says it can be any number 5 or less. So it can't be B and it can't be D. So now I'm looking what's left over for my A and C options. I now need to go through and decide what about my coefficient of A. And my missing coefficient of A, if I'm comparing A to the 6, and again, LCM, that least common multiple. So remember, multiples of 6 are 6, 12, 18, 24, so on and so forth. What number could A be? Well, if I go through and pick the first one, A, 9 or 18. Well, if I choose 9 or 18, its least common multiple that would match with my 6 would be the 18 in both of those lists. And that's what I have here. Whereas if I compare it with C, the missing coefficient can be any multiple of 3. Well, if I randomly pick a multiple 3, that would be, let's say, 12. If I compare 12 and 6 as their LCMs, I actually would have 12 being the LCM. So I know it can't be just any random multiple of 3. So that's why my final answer is A. If we look at this next problem, it's just a factoring problem, right? A simple one. These are the ones that we talk about, just get it and be done with it. If I want to go through and factor this, remember, I'm thinking to myself, what two numbers multiply to a negative 40 but add to a 3? Well, a positive 8 and a negative 5 are my two options there. And when I look at my option choices over here, the only one that could be is B, the x minus 5. On this problem, hopefully you see one of these on every Keystone test here. So when you look at this problem, before you start stressing about this, again, remember one option, they're telling you what not to pick for x. You could always go through and let x be your favorite number. Don't pick 0 or 1, and don't pick the negative 2 or 2 that they're telling you here. So you could let x equal 5 and go through and plug 5 in for all of the x's that you see here and all of the x's that you see there. And then go through and figure out what would be your best, or what your match would be. So that's always an option. The math behind this problem, though, is if I would actually go through and simplify this numerator, I would get x squared minus 5x minus 14, and then on my denominator I'd have the x squared minus 4. Now keep in mind, this is a math test. They're going to factor. So if I go through and factor this rational expression, and I'm going to say, well, what numbers multiply to a negative 14 but add to a negative 7? Well, my two numbers would be a positive 2 and a negative 7. And then my bottom one factors it into, that's one of your special ones, right? X plus 2, x minus 2. And right there, those two guys cancel, and you can see we are left with the binomial over binomial of x minus 7 over x minus 2. So answer B. If we look at problem 5, they're showing you basically somebody solving this problem here, and they jumped a step. And so when you go through and you read these 4 answer choices here, what is the step that's most likely missing? Well, just stop and think about, well, what happened to get to this point here? So they either went through, and again, looking at my 4 answer choices, I realized they've dealt with my x's first. They added 6x to both sides, right? They went through and they added 6x here and added 6x over here. And so that's where they're getting a 4x and would still have a plus 6 equals a negative 24. So just knowing what the correct answer should be there, right? Just by going through and saying, okay, this is what I should have here. I can see now what I can save and eliminate from my answer choices. So I know it can't be A or it can't be B because of they both having the minus signs in there. So I'm down to C or D. And when I look at my answer, my justification, think about what would make sense more here. This step is justified by the additive property or the multiplicative property of equality. Well, what did you do to both sides? You added. So that's why it's choice C. Okay, on question 6, this is an interpretation of an equation. You don't have to write the equation. After you read about Deshaun having a box of batteries and sort of matching up things that are alike, right? When we go through here and we see things that match up, we see that the batteries, there's 1.5 volt batteries, and we have 9-volt batteries, and we have that there's a total of 78 volts in a box. And see how everything matches up down here, and we have an answer of 10,7. Well, think about what this means. If the 10 matches up with our x and the 7 matches up with our y, and our 10's being multiplied by 1.5, that means I have 10 1.5 batteries. So looking at A and B, they're both saying that there's a total of 10 batteries. So that can't be A or B. And between C and D, 10 batteries that provide 1.5 volts each is that correct statement. And keep going here. 7 batteries have 9 volts each. And that makes sense for my 7 and my y. D is the wrong answer because it switches those up. It says 10 would belong with the 9 and the 7 would belong with the 1.5. When we look at the next problem here, where basically they are giving us a picture of a system. Now, again, you have a graphing calculator. So if you really wanted to, you can go through and put those into your graphing calculator and confirm which one of these graphs looks like it. But I could also go through and eliminate A and C right away because it's saying that there's 2 solutions. And we all know that we can only have one solution whenever we have a set of intersecting lines. So then it comes down to B or D, where there's only one solution. And again, we could graph those on our calculator and see what they look like. I could go through and look at both of these and say, well, I have a y-intercept of 1 with a slope of 1/2. So here's the y-intercept of slope 1, and a slope of 1/2 does not match that picture, where it does match that picture here. So that's why D is my correct solution. Again, here's a problem where they are basically giving us the graph as an answer. They give us a scenario here, and they have said the graph below shows the number of lily bulbs, X, and the number of iris bulbs, Y, that Calvin would plant. So they are just basically asking you to interpret the solution to this graph. And so the intersection is this point right here, 10, 30, where 10 is the X. Remember, X is about lilies. And 30 is the Y, and Y is about irises. So the correct answer has to match up with that labeling. And so this correct answer then would match up with being C, 10 lily bulbs and 30 iris bulbs. When we look at this next problem, don't let it stress you. You can always look at this problem and start with figuring out what the solution set they've given you and plugging it back in, right? It's just a formula. So if we actually look at this and think about this in terms of like, let's just pick a number, and the number I'm going to start with, and I know I say always never pick 0, but they're allowing us here to pick 0, and if it works, it's going to be either C or D. If it doesn't work, it's going to be A or B. So let's plug a 0 in first. And if I plug in 0, 2 times 0 is 0, minus 1, absolute value of that, less than 7. So 0 minus 1 is negative 1. Absolute value of negative 1 is 1. Is 1 less than 7? And you're like, yes, 1 is less than 7. So that means 0 is a possible answer. So that means I'm going to eliminate A and B from my answer choices because I know 0 could be a possible answer. So now when we look, So now when we go through and we look at our other choices, and what's left over here. So now I have to decide between C and D. And looking between C and D, the only difference is with like one of the endpoints being included or not included. So let's try 4 now. If I plug 4 into my inequality, and 2 times 4 is 8, minus 1, absolute value is less than 7. 8 minus 1 is 7, absolute 7 is 7. Is 7 less than 7? And the answer to that is no. 7 is not less than 7, right? That's false. 7 is less than or equal to 7. So that means 4 is not a possible answer for X. So it can't be C, and the correct answer then is D, because 4 is not allowed to be X. Here's another inequality problem with this. And with this guy, again, you could go through and do the same thing that we just did. I'm going to do this one algebraically, but you could do the same thing we just did here if you wanted to go through and like start with testing numbers like 0 and see which ones work. But for this problem, I'm actually going to go through and actually solve this guy. So I'm going to start with distributing there. So I'm going to have a negative x plus 2 is greater than negative 3x plus a negative 6. And if I go through and finish solving this guy, I'm gonna start with adding 3x to both sides. So I'm going to have 2x plus 2 is greater than negative 6. And I'll subtract 2 from both sides. So I get 2x is greater than negative 8 and divide both sides by 2. And I get x is greater than negative 4. And there was no big switch here, right? There is no dividing by a negative number or multiplying by a negative number on both sides. So I don't need to worry. So my final answer here is x is greater than or equal to negative 4. So when I look at my answer choices here, there's my negative 4. I should be looking for something with an open circle, so it can't be C or D. And which one shows me numbers that are greater than negative 4 would be B. So there's my final answer. Okay, when we look at this problem, we have this problem about Sam going to an amusement park that he has $61 to spend. And when you've done going through and reading about how he has to pay his entrance fee and how much each game is and how much it costs for each ride, they give you some information saying, well, he plays 6 games, so he spent $18 there, and he cost $20 to get in. So that's where that 38 came from, and adding to it $4 per ride. Right? That's where these numbers came from. They are giving you this. They're not asking you to dispute that or create that. They are giving you that. And the reason why it needs to be less than or equal to 61 is because he only has $61 total to spend. They went through again and did the math. How nice of them. They're telling you the answer is x is less than or equal to that 7.75. You have to interpret that when you read these. So you have to stop and think, well, again, if you look at this problem, x is representing the number of rides. So when we're saying this, it makes sense that his numbers of rides has to be less than or equal to 5.75. Well, there's no way he can ride 0.75. So basically, he needs to ride 5 rides or less. So when you go through and you read these statements, the only one that makes sense that matches up with that 5 rides or less would be option A. He went on at most 5 rides. Okay, last but not least for module 1 here. April's purchasing bottles of orange juice and bottles of apple juice from the store, and they give you this whole blurb about how she is spending her money and how much they cost. The graph below shows the situation. So they are giving you the actual graph again. So you don't have to do anything other than interpret the graph. So whenever you're reading this, which statement describes all possible solutions where x equals 2? Well, figure out where x equals 2 at. So here's our x-axis, here's where x equals 2. That means our bottles of orange juice is 2, okay? So April purchased 2 bottles of orange juice. April purchased 2 bottles of, right? If we look here, these two are saying she's going to purchase 2 bottles of orange juice. And on C and D, it says she will purchase at least 2 bottles of orange juice. At least 2 bottles of orange juice. That's not what we're talking about when we say x equals 2. So right away, I can eliminate C or D because I want x to be 2, not at least 2. So between A and B's answers, we look at the part about the apple juice. It says April purchased 4 bottles of orange juice and 4 bottles of apple juice. Well, if I compare where 2 bottles of orange juice and 4 bottles of apple juice is, it's not in that shaded area. It's that spot right there. So A doesn't make sense. And I'm going to double check to make sure B makes sense. April will purchase 2 bottles of orange juice and no more than 2 bottles of apple juice. And that makes sense because the most we cap out to stay in that shaded area there is at 2 bottles of apple juice. So B is our correct answer.